All right, so today we're going to do the Beanium Lab activity together. The first thing we're going to do is read the background information. So for elemental samples, a mass spectrometer is used to measure the masses of each isotope as well as their relative abundance. The results of these analysis is reported on a table of natural abundance. And you can go look that up if you're interested. So the problem is to take a sample containing different types of beans. Each type of bean represents an isotope of the element beanium. Each individual bean represents an atom of the element beanium, and your job is to determine the relative abundance of each isotope, the average mass of each bean, and the average atomic mass in grams of the element beanium. So, you'll need a mixture of beans, an electronic balance, and instead of a plastic cup, we are going to use a weigh boat. So first we need to obtain our sample or classroom mixture of beanium. So I've got my sample here of beanium, and then I'm going to, before I obtain my sample, I'm going to write my hypothesis. My hypothesis is if the mass of each isotope is different, then the average atomic mass will be between the highest and the lowest mass. So now I've written my hypothesis. I'm grabbing my bag of beanium, and then my first instruction is to sort your beanium into 3 isotopic bean types. So I've already done that as my beans move around and shift. So I've got my 4 different types of beans right here, my 4 different isotopes. And then I'm going to name each one of them. So I'm going to start here with this white one, and these are navy beans. And then I've got pinto beans. Then I have black beans. And I have garbanzo beans, or chickpeas. So now I'm going to count each bean in my pile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have 24 beans, 24 navy beans. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pinto beans. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 black beans. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 chickpeas. Now, I need to find the mass of each pile of beans. To do that, I'm going to place my weigh boat on my scale. I'm going to zero out my weigh boat on my scale so that weigh boat now it weighs 0 to the scale. I'm going to take my weigh boat off. I'm going to put all my beans in. My weigh boat. I'm going to weigh my entire mass of beans. So I've got 5.0 grams. My mass of bean samples. Then I'm going to pour this back into my baggie. I'm going to keep 2 beans out just to make my life easier later on. And I'm going to move on. I'm going to do the same thing with my pinto beans. I'm going to keep 2 pinto beans out. I'm going to pour them into my bag. I had 6.8 grams. I'm going to repeat again with my black beans. .6 grams. Keep 2 of my beans out. And then I'm going to repeat with my last one, my chickpeas. Right. 7.3 grams. I'm gonna keep 2 chickpeas out. Gonna put them back into my baggie. All right. Now that I have all of my average beans, I'm going to determine my average mass of one bean from my sample. And to do that, I'm gonna move the scale. I'll move it right back, but I want you guys to be able to see, right? My average mass of one bean is going to be 5.0 grams. So I'm going to take my mass of my sample and divide it by the number of beans in my sample, 24. 6.8 divided by 17. 23. Whoops. 4.6 divided by 23. And then finally, 7.3 divided by 15. All right, you'll plug those into the calculator. You'll get those numbers. Then we need to figure out the individual mass of our beans. So we're going to bring our scale back over here. All right, I'm going to lay this down. So first is my navy bean. Individual mass of 1 is 0.1 gram. Put this one back in my baggie. Again with my navy bean, 0.2 grams. My pinto bean, 0.5 grams. .5 grams. Black bean, back in my baggie. Black bean number 2, all right, so now that I have this table filled out, I'm going to go and answer the questions right here on the back. I will see y'all next time.